All right, so I'm going to record this and I'll put a link on there. So in case we go a little bit too quickly for you guys, you could look back. And this trig equations, we're going to be solving trig equations, sometimes can be a little difficult. So in my notability now, I'm going to make a new note. Remember, these are the things that we've already done. We did the right triangle trig stuff. The unit circle, this is a huge concept, and that's going to be huge for our trig equations. So now I'm going to create a new note, and I'm going to be solving trig equations.
Is this a new note?
Sorry?
Is this a new note?
This is a new note, yes, a new note.
Okay.
Yeah, because this concept, I think, is going to maybe even take us a couple class periods to get through. But if we wanted to solve this equation, okay, the sine of x is equal to 0. So what that question is asking is, we're trying to solve for x, just like we do often in math. Well, x is an angle in this case. We want to know what angles do we take the sine of to be equal to 0. So I'm going to real quickly draw a unit circle, and there's no way I would want to fill in all of that information, you know, all of the different parts. But it's really important for us to be used to these reference angles. So this we should be able to do pretty quickly. That's pi over 3, it's pi over 4, and that's pi over 6. And also knowing the coordinates at each of those places. So the first quadrant is really important for us to get used to. Now you can remember that these numbers go 1, 2, 3 to try and help you keep your numbers straight. So that first coordinate at pi over 3 is going to be 1/2 and root 3 over 2. Pi over 4 is, I think, the easiest one to remember, root 2 over 2 and root 2 over 2. And then pi over 6 is root 3 over 2, 1/2. Because if I have those down pat, if I have my reference angles down and I can figure out what quadrant we're in, then I can solve almost all of those trig equations. Now this question is asking, when is the sine, which is the y value, equal to 0? So thinking on the unit circle, the y value is 0 here, and then the y value is 1 up there, but it's also 0 down here. Okay, so the y value is equal to 0 in those two places, here and here. So when we're writing our answer, we're going to say that x is equal to 0 and pi. Okay, it equals 0 here, the sine is equal to 0, and then the sine of pi is also equal to 0. So you might be asking yourself, well, why don't we say 2 pi? Because 2 pi also is a possibility, and that would be correct. So what I'm going to do is I'm going to limit our original problem, and I'm going to write this up here, that we're going to solve trig equations for x. And this little symbol means x is in 0 to 2 pi, inclusive of 0, but exclusive of 2 pi. So that means essentially for one loop around the unit circle. Okay, so we're solving these only for one loop around the unit circle. All right, so let's do another one here. I'm going to find the cosine of x is equal to negative root 3 over 2. Okay, the cosine of x is equal to negative root 3 over 2. So I'm trying to find the angle whose cosine is negative root 3 over 2. Well, I know the cosine is the x value. And so the x value is root 3 over 2 right here at pi over 6. But I want it to be negative root 3 over 2. So that means if the cosine is negative, which is the x value, it's going to have to be here and here. It's going to have to be in the second and third quadrants. So it's going to be negative 3 over 2 at 5 pi over 6 and at 7 pi over 6. So those are my two answers, that x equals 5 pi over 6 and 7 pi over 6. So that's where and you can kind of check it, what is the cosine of 5 pi over 6? It's going to be negative root 3 over 2. What's the cosine of 7 pi over 6? It's going to be negative root 3 over 2. All right. Any questions so far? No? All right. Well, then the next one is going to be just a little bit harder because it's going to involve a little algebra, but nothing that we can't do. Let's say we have the equation 4 sine squared x minus 1 is equal to 0. All right, so, using a little algebra, we're trying to solve for x, so we got to get that part by itself. So the first thing I'm going to do is move the 1 over by adding 1 to both sides. So I have 4 sine squared x is equal to 1. Then I'm going to divide both sides by 4. So I have sine squared x is equal to 1/4. Now I'm going to take the square root of both sides. So that means I've now solved it for the sine of x, and I have the square root of 1/4, which is the square root of 1, which is 1, and the square root of 4, which is 2. So I have the sine of x is equal to 1/2. And don't forget this part. Okay, so if you're looking down at your papers, look up at the screen. When you take the square root of both sides, you have to remember it is plus or minus. So we have sine of x is equal to plus or minus 1/2. So that means we now have to find the angles where the sine is equal to positive 1/2 or negative 1/2. Remember, the sine is the y value. So the y value is positive 1/2 here at pi over 6. It's also positive 1/2 here at 5 pi over 6. And it would be negative 1/2 here and here. So we actually have 4 answers. Okay, our answers are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Those are all the places where the sign is either positive 1/2 or negative 1/2. Okay, pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. So x is equal to all 4 of those. Pi over 6, 5 pi over 6, which is in the second quadrant, 7 pi over 6, which is in the third quadrant, and 11 pi over 6, which is in the fourth quadrant. So you can see by the example, sometimes we get 2 answers, sometimes we get 4 answers. It just depends on the type of problem we're looking at. Okay, I'm going to do another one that's kind of similar. So let me know if I'm going too fast. I can slow down for you guys. Happy to do so. Let's say we have 4 cosine squared x minus 3 is equal to 0. So just like in the last problem, we want to get the cosine by itself. Okay, we got to get this thing by itself. So I'm going to add 3 to both sides. So that's 4 cosine squared x is equal to 3. And I'm going to divide both sides by 4. So we get cosine squared x is equal to 3/4. And now we have to take the square root of both sides. And don't forget, when you take the square root of the right side, it's plus or minus. The square root of 3 is on top, and on the bottom is the square root of 4, which of course is 2. So we did the algebra. We're kind of like, in this step from the problem above, we then just have to find all places where the cosine is root 3 over 2 or negative root 3 over 2. So let's refer back to our reference angles. The cosine is the x value, and the x value is root 3 over 2 right here. So pi over 6 is one of our answers. That's good. The x value is negative root 3 over 2 right here. So 5 pi over 6 is one of our answers. And it's negative root 3 over 2 here, so 7 pi. And it's positive over here at 11 pi over 6. So we have, again, 4 answers. We have pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. Those are our 4 answers for that problem. So our x values are pi over 6, 5 pi over 6, 7 pi over 6, and 11 pi over 6. All right, any questions on that one? So we did that class kick, and I want to go over a couple of those questions. And when you are doing these, I think it's a good idea to get in the habit of drawing your first quadrant. So I'm just going to draw that real quickly. And it would be a waste of time to draw the whole unit circle. Don't do that. But I do think you should get really good at doing this, knowing that's pi over 3, that's pi over 4, that's pi over 6, and then writing our coordinates here. Remember that they go 1, 2, 3. And so that's 1/2 root 3 over 2, root 2 over 2, root 2 over 2, and root 3 over 2, 1/2. So, I'm trying to just model what I would do if I were a student. And because I think just knowing this part is going to help me solve all of these questions. If I want to find where the sine of theta is equal to 1/2, I know that the sine is the y value. So I'm looking, where is the y value equal to 1/2? Well, it's right here. The sine is 1/2 there. I also know that the y value is positive in the second quadrant. So I have to answer pi over 6, but I also have to answer 5 pi over 6. So those are my two answers for the first problem, that the sine is equal to 1/2 at pi over 6 and at 5 pi over 6. Okay, to find where the cosine is equal to negative root 2 over 2. Well, I know the cosine is the x, and the x is positive root 2 over 2 here, but I want it to be negative. Well, the x is negative in the second and third quadrant. So I need those 2 points right there. So if I know that pi over 4 is my reference angle, then 3 pi over 4 and 5 pi over 4 are my two solutions, because that's where the cosine, which is the x value, is negative, and my reference angle is pi over 4. So it's at 3 pi over 4 and 5 pi over 4. So theta is equal to 3 pi over 4 and 5 pi over 4. All right, what other ones would you guys like me to do? Come on, be brave, ask a question.
The one on the second page, it
Okay.
was and then B.
B, all right, let's do B. So it is 3 tan theta is equal to root 3. So we want to get the tangent of theta by itself. So first thing we do is this. Divide by 3, okay? Now, I'm glad you asked this one. This is a hard one, a really hard one. So we want to know, where is the tangent root 3 over 3? All right, well, I had that unit circle on the other page, but I'm going to redraw it down here because I just think it's good practice to draw in that first quadrant. So the more you do it, the better you're going to get at it. So I'll just do it real quickly, because I'm hoping that you guys get used to doing this real quickly. And I want to know, where is the tangent root 3 over 3? Well, remember, the tangent is sine over cosine. So it actually is root 3 over 3 right here, and I'll show you why. Because at pi over 6, the sine is 1/2, and the cosine is root 3 over 2. So when I do sine over cosine, 1/2 over root 3 over 2 is 1 over root 3. Which, if you rationalize, so you multiply top and bottom by root 3 over root 3, we get root 3 on top and 3 on the bottom. So that's where the tangent is root 3 over 3. Okay, so that is definitely a hard one. That happens at pi over 6. Okay, so at pi over 6, it's 1/2 over root 3 over 2, which reduces to root 3 over 3. So theta is equal to pi over 6. Now the tangent is also positive in the third quadrant. So I also need that as my answer, which is 7 pi over 6. So that is my second answer, 7 pi over 6. Those are the two solutions for that one. And that's a really hard one. So if you followed all that, you're in really good shape. All right, what else do you guys want me to do? Come on, let's do at least one more. Somebody choose one, either from the first page or the second page.
Can you do C from the second page?
Yep. All right, here we go. We have to get this part by itself. So we'll move the -4 over by adding 4 to both sides. So we have 2 cosine theta is equal to -2. And then we divide by 2, so we get the cosine of theta is equal to -1. All right, so we got that by itself. Now we're trying to find the cosine is the x value. Where is the x equal to -1? That is going to be right here, because the coordinates straight to the left, because it's unit circle, remember the radius is 1, so the coordinates are -1, 0. So that means at an angle of pi, the cosine is -1. So pi is our answer. Okay, the cosine is equal to -1 when theta is equal to pi.